Okay, let's go back. So how to calculate quantities? For us to calculate quantities, we have to first of all create something called a datum surface. So earthworks in Civil 3D are done or are calculated by comparing two surfaces. Okay. So what we are going to do today is that we are going to create, for example, let me show you a cross section here. We are going to create um, a surface down here called the datum surface. Okay, the datum surface. So underneath our corridor, and I'm looking for a place where we have a, a cut situation. We will calculate. We will do create a surface that is underneath our road corridor like this, called a datum surface. Okay, and that datum surface is what we will compare with the existing ground. As you can see, this is an existing ground. If I hover over that, that's the existing ground. So if you compare this and this, if you do a comparison between these two surfaces, you can be able to get this earthworks, which is in between those two surfaces. Okay. Okay. Also in fill, that's the same case. If you compare these surfaces and this existing ground surface, you can get the material in between here. Okay, that was fill. So this is not part of the earthworks because these are road pavement layers, and we can see how to calculate those road pavement layers in another way. Okay, so this is the area so of in which we can find the yes the fill, the earthworks. Okay, so there's a fill that will happen here. Okay, so how do we do that? We do that by um, coming to the analyze tab here. And here at volumes and materials, you will see a lorry here. And you can click on that to compute materials. Okay. So let me click on this. So select alignment. So before we do that, we need to create that datum surface that I was talking about that we'll compare with the existing surface. And how do we do that? We pick the corridor. Let's first of all pick the corridor and create that surface. I right click and go to corridor properties. And here at the corridor properties, there is this option here called the surface option. And I want to create a bottom, a datum surface. So first of all, I create a surface here, create a corridor surface. Okay, I click on that. And then I rename it here and call it datum. All right. And then I will use the links to create that surface. Remember point codes? So the lines are usually the links. The 2 points are core points. The shapes are those shapes in between. So the links are what are going to form the surface. Okay. And then these links are the datum surface, the datum links, the links underneath the road cross section. So that is, those are what are going to create this surface. So once I dictate that, I click on add. And then I add that as break line also. Okay. And then I apply. And as you can see, a surface has been created here. But now it's triangulating all the way here. So we will sort that out. Let's just look at how it looks on object viewer. There is your surface. It's underneath the road. So this is how the the bottom of the road looks like. But now we need to put a boundary here so that it doesn't regulate past the road boundary. Okay. So how do we do that? We just click on the corridor again. We right click, corridor properties, and we go to boundaries. And here at the datum, we need to add corridor extends as outer boundary. So let's add that. Apply, click on OK. And now that surface that we created, the datum surface, it has that boundary. Oh, sorry. Let's see it in object viewer. That's the bottom of the road corridor. So this surface is what we are going to compare with the existing surface so as to get the cuts and fills. Okay. And we have to add this to our sample lines. We have to sample it. Okay. So currently our sample lines only sampled they only sampled the existing surface and the road corridor. So we need to add to our sample lines the datum corridor. Otherwise, if we don't, we will not, when we try to compare the two surfaces, we won't find the datum surface. So I turned off the layer of the sample lines. So let me turn on all the layers that exist in our drawing. So there we go. We can now see our sample lines again. So if I pick on sample line, I will see on any sample line, I will see the contextual tab of the sample line. And here at the modify, we can sample more sources. So I want to sample more sources. I want to sample the road data. So I add it and I can pick a different style for it. I can pick finished ground and I can even change the color for finished ground in it's blue in section. Okay, let it appear blue. Okay, finished ground. I've added that so the sample line will see it, and now we can use this datum surface to compare or to calculate material. So once I'm done, I click OK. Okay, we've sampled more sources, and I can turn off again these sample lines if I don't want to see them. So I can click here. So if I hover here turns off the layer of a select object. So let me turn off this layer and also this text. Okay, I'm left with the other objects. Okay, now let's now go to the analyze tab and compute. So here at the volumes and materials panel, I will click on compute materials. And here, selected alignment, we only have one alignment. Sample line group, we also have one sample line group. So we can click OK. Here we can do a quantity takeoff criteria for cut and fill. Let's just do for earthworks. And as you can see, we need to pick an existing ground. Existing ground is a topo surface. The datum surface is the road A datum that we created. So if we had not sampled it, it wouldn't appear here. So we would wonder where to get a comparison surface. Okay. Okay. So there are various volume calculation methods: composite volume, average end area. Let's see whether this is better, because average end area I think is good for average end area for symmetrical shapes. Okay, now that we've done that, we can now click Okay, so the computation has happened. What we now need to do is to create a report for it. So here we can click on generate a volumes report. So we only have one material list. So here select a style sheet, select earthworks, and then we click OK. And here you can see now your volume report. Okay, and I think you can save as, or you can print it, or you can control A, right click, copy, and paste to something else like Word or Excel. Okay, and you can format it to your liking. And as you can see, area being filled, volume being filled, and then you can have here cumulative cut, cumulative fill, all these earthworks. You will get them here. So much of our works actually is it fills. Yeah, this is cumulative cut. Okay, it's actually cut. Okay, so that's how you compute those materials, and you can save that to whatever place you want. You can also create a volume table report, a volume table, I mean, which will have like the same information. Volume table, if you want it on Civil 3D, you have that style. Materialist one, I don't want to split my table. I want my table to be dynamic. So I can click here and I will have the cumulative fill, cumulative cut volume, cumulative fill volume, cumulative cut volume. Okay, we can have that here as a volume table. And if you want to show it in a Civil 3D drawing, you can show it. Okay. Now, next, we would want to calculate the materials of the pavement. The materials of the pavements, like the asphalt, like the base material, sub base. How do we do that? We can again compute. You can go to compute materials. Okay. I don't know whether we have mhm, so material list. Let's see how this looks like. So pavement material, and then base material. So the problem is this: we have two asphalt materials, and yet here we have only one pavement material. Pave. So we cannot choose both pave one and pave two. As you can see, our road corridor consists of two asphalt coatings. This one, and then base, and then sub base. So if you want to create a material list of our own or a criteria of our own, we have to go to tool space, to go to settings, and where you see quantities, quantity takeoffs. quantity takeoff criteria. You can create a new quantity criteria takeoff here and call it um, pavement materials. And then here for the material list, the data type is a corridor shape. And then you can choose um, okay, first of all, let me add a new material and call it pavements, my asphalt. And then under this, I call it structures. Then under this, I add a corridor shape, and then I also add another corridor shape. So the two layers of asphalt are added. Then I add another material there for base. Okay, that is also a structure, not a cut. So corridor shape, base, add it. I add this subbase is a structure. I add it down there. Okay. So this is my pavement materials criteria. Um, and here I now save it. Okay. So here it is. So now when I go to analyze, I can compute materials and here I can import another criteria which we have now created. Okay. And pavement one, I can call it road A pavement one. I can assign this base. I can assign this. I click OK. The composite volume method cannot be used. Yeah, so here we'll use the average ended area. Okay. So let's now remember now for this one, material list 2 here. So I think we've now computed. So we can do a volume report now. Here we pick material list 2. And here we pick select material and then we generate a report again. So here I wonder why it's bringing us like a volume report, like an earthworks report. So what we can do to to get the individual pavement materials, we can do a material volume report here. So asphalt, yeah, we can do for asphalt. For asphalt, we can get the quantities of asphalt. Okay. So this is the lami that you're going to use. Those are the quantities. So let's do for base. don't want to split the table. Okay, this is the amount of base. Okay, let's do subbase. To your volume report. I don't want to split the table. I want to pick subbase. Click OK. And there you go. So now you have the quantities of each, the volumes of each layer. So this is in cubic meters, I presume. And then this is in cubic meters, and this is also in cubic meters. So you can now put that in the BQ, for example. Okay, you know the excavations that are going to be done, you know the amount of reusable material. If that material is, if the cut is going to be reusable, you can get that in the reports. And then you can even get now the volumes of the lami, the base, and the subbase. Okay, so that's how we do the quantity takeoffs. Now, we need to proceed to pipe works. Okay, pipeline design. Now, beside your road, there might be a storm sewer or a sanitary sewer. Okay, so what I cover here in pipe networks, I usually cover the gravity networks, not the pressurized networks for water supply. So in this course, I only cover the gravity networks. And before we even go further, the first thing when we are doing those pipe networks is we set up the rules. Okay. Um, okay. Or let me just show you something here. Or even before setting up the rules, there's something called a parts list. Parts list. Let me see. Here at settings tab at the tool space. So let me see here. Okay. This pipe styles, pipe rule set. Let's see where we can get a pass list. Pressure networks, pipe networks. Um, Pipe networks, pipe. Mhm. Pipe networks. Okay. So here, for example, if I go to pressure network creation tools, there is a standard pass list here. Sanitary CO standard pass list. So we can create one of our own. So I'm trying to find where these pass lists are. So let me first go to settings, pipe networks, or pipe networks. Yeah, so pass lists are here. Here at the settings tab, there are some pass lists here, and so there are some which come with CO3D. So there's storm sewers, storm sewer, sanitary sewer, pass list, standard pass list. Okay, so we can just open up one pass list to see how it looks like. So the pass list for sanitary sewer, here at the structures, we have all these manholes. These are we have these kinds of manholes. Concentric structure. Um, there are some eccentric cylinder structures. Okay, some null structures. For pipes, in this pass list, we have some PVC pipes and in all these diameters. Okay, so actually we can use this pass list. We don't have to create a pass list of our own. So this is the pass list that we will use. But just in case you needed to create a pass list of your own, if you don't want a pass list that has so many pipes, you can create a pass list that is small, that is is a small one with a small range of pipes. Okay, if you're sure about pipes, like in Kenya, we don't use 75 millimeters for Siwa, 90. I think the smallest we use is 200. So if you don't want to see this in your pass list, you can create a pass list of your own. Okay, you can copy or you can cancel this, or you can come to pass list, create pass list, and here you can add part family, and you will see you have a catalog here to choose from. If you want PVC pipes, if you want HDPE pipes, you can see the preview. Corrugated pipes, although they don't show the whole difference, but if you want a different shape, you can see elliptical. Okay, if you want rectangular pipes, so this is how they are created. So for example, if you wanted PVC, okay, and then after you create that pass list, you can now add part sizes. So you can now come and select part sizes of your choice. A material is PVC. So here you can type or here now the diameters of your choice. If you want to start from 200, you can pick 200, and down here you can now see you have the size of choice. You can add, oh sorry, you can add another size that you want. Okay, and here in structures you can also add part family if you want. These kinds of, these are inlets and outlets. So inlets and outlets are used in storm sewers. So storm sewers, inlets especially, are used for storm sewers, but in sanitary sewers we mainly use manholes. So inlets are, if you in a street, for example, there is a place where the storm water will be entering into the storm sewer. So that inlet. So which one do you want? So these different kinds of inlets, rectangular head wall. Okay. And then now the junctions, which are the manholes. See the different kinds of junctions. You can add whichever you want. Okay, so we are not creating a pass list. We will go with the sanitary sewer pass list. So once we have a pass list, so maybe the next thing is to do the rules. Okay, so our design criteria. So here there's some rules here. Pipe rule set, basic. So we can create our own. And here at the information tab, we can name it. Our pipes, we want to add rules. So don't worry about this. So let's written in Storm Sewer, but do not worry about that. So we can have a rule about cover and slope, okay, for our pipes. So let's click OK. And here now we can change these parameters. So minimum slope saying 1%. Okay. Maximum slope, let's go with 10. Minimum cover, It can be 3 meters. This is very big. So minimum cover, we can say 1 meter. Maximum cover, so 10 meters is quite deep. We can say 5 meters. Okay, but there are sewers which go up to 10 meters if in flat areas, because you don't have a gradient that is sloping so that you put it in a shallow place. And you know it has to flow through gravity. So you will have to go deeper and deeper. But here for now, let's do a maximum cover of 5 meters. Let's see whether we should add another rule. This is another length check, set pipe to pipe, cover only. Don't want any other rules. Sorry. Delete rule. We had set up our rule. So that one, we are okay with that. So here is our rule. So the next other thing we can do here, we can set up a rule for the structures. Structure rule set. We can create our own rules. Let's add a rule. Drop across structure. Pipe drop across structure. Uh-huh. Drop represent location, invert, drop value. Let's see whether we maximum pipe size check. Okay, so let's add this pipe drop across structure. Let's set these parameters. Drop value. Let's put 0 and 0. Okay. Let's add this other rule. Send sub depth. 0 is okay. So once we are done with that, click OK. So we set up our rules. Now the thing is, we need to assign them to our pass list. Okay. Sanitary sewer, edit. As you can see here, the rules is for all our pipes is basic. So we want to change that to the one we created. Okay, so we can change for all pipes up here. Structures also, rules here, we will use the concentric cylindrical structure. So here, let's change it to our rules. Now that we've set up everything correctly, now we can go to start creating the pipe network. So we want to do a sewer next to the road. We do it down there. So what we now do, we prepare pipe network. We do pipe network creation tools. We can call it network 1. Okay. Our pass list is the sanitary sewer. Surface is the top surface. Lemon name. This is just to help you in referencing. And then structure label style. Only name. Sanitary pipe label style. Plan length, description, and slope. Okay. Now that we are done, we presented with these network layout tools. And here we can choose our manhole. So concentric, 1500, that's okay. And then we can choose our smallest pipes that is used in Kenya. Okay, so these icons is just for setting up the surface. This is what we've set up in the initial stages. So here is where we now get to select the pipe size. So it's showing you the insertion point, draw pipes and structures. You can decide to draw structures only, pipes only. We want to lay out both pipes and structures. And here is showing us we are toggling from upslope to downstream. Okay, so as we put our manholes and pipes, we'll be going from upslope, from upstream to downstream. This is for deleting pipe network objects. This is for viewing your any in-grid view. Okay, so now once you're done, just click on, oh, sorry, just click here on pipe and structures. So let me put off snaps. So let's say our first manhole was here. So we can be doing our manholes 60 meters apart. There are those rules that you also need to know. You should have done a length check also, a certain maximum distances for for pipes between manholes. But we know also every time you change direction, usually there's a manhole. Okay, that was taught in class. So maybe our outfall is there. We can enter. Okay. So now we can see how our drawing looks like. So we change the annotation scale. So 51 meters, the pipe's 51 meters. This one is 59. Okay. We can now view this network on our profile view. If you want to see it on profile view, we can click on this, any part of the network. And once our contextual tab shows up, we can draw paths in profile view here at network tools. We can click on draw paths in profile view, select profile view, you can choose this one. So it's only showing us our manhole here. So what we can do, if we want to see all the manholes, we can go to this profile view properties. And as you can see, there's a new band here, on tab I mean. So if you want to see all of them, you can click on all of them. There you go. You have your CO. So the reason why you're seeing it as though it's underneath the surface here, of course the rim usually is above the surface, this rim. The reason why you're seeing it there is because it's not at the middle here, it's at the side. So, and this surface profile in red is for the middle here. So these are on the side. So that's how they look like. Okay. And for editing, this network, you can use grips. Okay. If you want to move your pipes, okay, you can use grips to modify how your how your layout looks like. If you want this to go deeper, so these scripts can help you to. You see, there's some. You see, it's not a must for pipelines to for sewers to be straight, but there's some engineers who want this profile to be as straight as possible. They want this grade to be similar. So you can use those grips to modify to to modify it to what you want. Okay. And also you can label these pipes. Okay. Um Here the contextual tab. Let's see where is label. It's not here. Oh yeah, add labels. Entire network profile. Select part. As you can see, you can add labels to your structure, showing you the station, the rim, sump. Okay. And once you're done, if you want to analyze this network, you can take it to edit installment sanitary sewer. That's a lesson for another day. We won't analyze it. Or there are various other softwares which also analyze, but I like using this one. So, but there are these softwares which also analyze whether the sewer is sufficient. So you might realize if you put loads, sanitary loads to these manholes, you might see as you go downwards, maybe you need to increase the pipe sizes. So you can analyze that on some storm and sewer, uh, storm and sanitary package, and you will be able to see. Okay, so that's how you you design these sewers. The other thing we need to mention is that there's something called data shortcuts. Okay, there's something called data shortcuts. So data shortcuts allow you to bring in very heavy data to another drawing. All right. So let's say you are doing your civil 3D work and you find your computer very slow. So you want to maybe use a surface in this drawing, a very big surface in another drawing. You want to use it so that you do not um you not you do not overwhelm your computer using a lot of data. So you can leverage the that data shortcuts to do that. So how do we do it? So for example, I want this surface in another drawing. So what I can do, let me go to Prospector. Here, the first step is setting a working folder. You can set up a working folder. I can add one here. And I select that folder. Okay. So once I've selected that, and now I need to set data shortcuts project folder. Okay, let me see first of all what new data shortcut. Okay, so in November, in my working folder, I have a new data shortcut folder. In my working folder, I have a new working folder. So once I have that, I can create a data shortcut. And here I want only the surfaces. And maybe I may only want the top of surface. That is what I want to share. That is the data I want to share. So I click on OK. Okay. So if I open up a new drawing here, for example, and I want here in data shortcuts, I can come to data shortcuts and I create reference. And I can even change the style. Let me use that style. And you can see now I have my surface. And now this drawing will be very light. This drawing will be very light. So this this if I do alignments, corridors, and this, the fact that this um, surface is in another drawing makes my drawing very light, so it does not overwhelm my computer when I'm automatically maybe updating corridors, adding more frequencies to my corridors. Doesn't overwhelm my computer. As you can see, that's how you can reference, can create a data shortcut. So these are some workflows I'm showing you that can help you in maximizing your computer potential. Now, the final thing before we close this training is to show you how to. What was the final thing? Oh, to create a template. Okay. So remember, as we were doing our our drawings, as we were drawing our drawings, we were creating styles from scratch. If you want these styles to be available, so each time you create maybe a profile view, it appears like this. You don't have to go creating this from scratch. You can save this as a template. Okay. So I can go to my application menu, save as, convert this to DWT. Okay. And I can name it template. Let's just say okay. And even if in this November template I delete everything here, okay, if I delete this, where is my initial drawing? I should have saved my initial drawing first. So, okay, let me see. Save as again. as a drawing. I like using the 2013. Oh, we already. Oh, this is for yesterday. So let me save this. Okay. So let me open my template. I want to delete some of these things here. November template, open. So even if you delete all this in your template, okay, and you save it, okay. So if you now open up a drawing, for example, here, let's open up a new drawing using the application menu. So remember, this allows you to open up using a template. So let's open with the November template. So you open up a new drawing with the November template. Let's bring in the surface. Let's let's create a reference for the surface. Let's click OK. Now, if I create an alignment, for example, alignment creation tools, here you can see we now have our styles that we created. Okay, we have our label sets. Okay, so when I'm creating, I can set up all these things without even going to create those styles once again. As you can see, these are the styles we created. Okay, if I'm to create a surface profile, our data band, I think we saved it. Did we save our data band? Yeah, band set is here. Profile view. Oh, here, profile view. We can set up the one which we already created, and we can create a profile view here, and it comes up with the settings that we already made. Okay, so that's how you create a template, and each time, if you want that template to be the default that is used when you even use the option where you're not allowed to pick a template, as you can see here, you can set that up in options. Remember options, template settings, default template. You can see you can select the template. Currently, the default template is Civil 3D metric, but you can use that. You can change it to the one you created. So I think we've come to the end. Any questions?
I think on my side I'm good.
Okay, thank you, Mboro. Fiona, today Fiona is very silent.
Yeah, yeah.
Yeah, okay. Then let's bring it to a close. It's been an honor to serve you in this way. It's been a good class.
I'm unable to unmute.
Engineer Elijah,
Yes.
I'm okay.
Oh, you're okay.
But I have a question.
Yes.
After the course,
Uh-huh.
can we still contact you if we have questions?
Yeah, you can.
Okay.
Yeah, I'm available.
So, alafu, when will you share the recording?
I will share by Monday.
Okay.
Yeah, I will have shared.
Sawa. So that we can practice.
Yes.
Okay, thanks.
Okay. And so on next week, I'll be doing an AutoCAD course. So you can inform your friends, or if you want to, also you can subscribe to that one.